Hello, everyone. Welcome back to the critique of our Dev Coding Challenge. We are now at week 7. My name is Roland, and together with me today, we have Ronald. Hello, Ronald.
Hello, everyone. This week, we saw a good number of you say this problem was not as hard as last week, so we're glad to hear that. Let's get into discussing the problem that you guys responded with.
Okay, awesome. Thank you, Ronald. So let's take a look at the problem. So the challenge today, I'm calling it Find Max Time. Basically, you're given 4 digits and you're supposed to find a maximum 24-hour time that you could form using the 4 digits. So valid times would be from 0000 all the way to 2359. So for example here, if we have 2902, then I made a mistake here. The time that you can make would be 2209, not 2290. So that's 2209. And then if the numbers were 4733, you can't form a time with that because you can't even form the hour, right? You can't, valid hours would be from 00 to 23, and you can't form that. If it was 0000, then the maximum time would be 0000. And then this last one, prior to recording this, Ronald saw my mistake. I said that 9016, you can't form a time, but Ronald correctly stated that actually you can form 1609 with it. So I stand corrected. So I'm going to pass this time over to Ronald now.
Yeah, thank you, Roland. So this week, lots of different responses, and because the problem looked pretty easy on the surface, we actually got a couple of different answers that we're going to look at today. But a lot of them were actually close, but it just a bit of a nuance to each of them that caused some of the time to go off rails. So the first example we're going to look at today takes the strategy of dividing each digit into different slots. So the first slot, they allow the digits to be 0, 1, or 2. In the second slot, it allows the digits to be 0, 1, 2, or 3. In the third, 0 to 5. And then the last, 0 to 9. So this is shown in over 2 slides. This first slide shows the helper function that is used to determine what number should go into each slot. And if we go to the next slide, this is kind of the full kind of algorithm that I kind of just went over with each slot having designated numbers. Now the problem with that strategy is actually, there's 2 problems with that strategy. Now, the first is it commits to using the digit 2 if it appears anywhere in the input right away. And that's a problem because if 2 is committed to, and then subsequently there's no correct digits that can fit into the second slot, it actually rejects that number as a valid time. And then the second problem is that in the second slot, there's actually a possibility to go beyond 3. So if the first digit is 0 or 1, you can actually go from 0 all the way to 9. So if we look at the next slide, here we have 2 examples of times that were missed. So for 9921, it is encountering the problem where it commits to the 2 way too early. The next digit, it'll take the 1, but then 99 is not a valid time for the minutes, so it gets rejected. And then for 1337, because it only allows digits 0 to 3 on the second slot, this time comes back as 1337, whereas the maximum time it theoretically could have been is 1733 instead. The next one takes a similar strategy in that it kind of divides each number into slots again, but this time this algorithm the student submitted to us was a little bit smarter. So if it finds the digit 2, then it knows to look for the second digit in the range of 0 to 3. Whereas if it takes the first digit as 1 or 0, then it knows to look for the max from 0 to 9 for the second digit. And then the third digit is still the same, 0 to 5, and then the fourth is 0 to 9. And this is covered in this slide here. Now, this one has just one flaw as well. It also commits to using the 2 way too early. So in this example where we have 9921 as the input, it's over enthusiastic about taking 2. So then the next digit will be 1. And unfortunately, 99 is not a valid minute. So again, it suffers from a similar problem as that first example, but it was a little bit smarter about it.
Yeah. Now, I wanted to actually. So this is part of the code, just a snippet of the code, and a bunch of if blocks that was submitted by this person kind of looked like this. And I wanted to have a discussion with you, Ronald. So this is the way this person formatted the if block. It works, so there's nothing wrong with the logic. But I thought it'd be good to kind of contrast and compare with a couple other formatting. So the top left is what the student has submitted. So, and then I show 3 other variations of this. What are your thoughts, Ronald, on what the student submitted and the pros and cons compared to the other 3 variations of this if-else block?
So, if we're just looking at the first one that the student submitted, what I see off the bat is the indenting is a bit off, and without just looking at it, it throws someone looking at this code off, because with that indent, it kind of implies that it's nested inside that if. But because the logic of the assignment logic is actually done in line, that's not what it actually does in reality. The else if is actually on the same indentation level as the if and the else. So just looking at it, it throws me off.
So the one on the right shows the indentation a lot more accurately, right?
Mm-hmm. Yeah. Now, I mean, I've definitely seen some code like the one on the upper right, but I think kind of the other 2 examples are what, I mean, you would normally expect when you're looking at code.
Yeah. So the one on the left here uses, I guess this is a trait of C languages, right? C, C++, Java, where you could have a single statement as the body of the if or the else clause. So here it's single statements. And then we contrast and compare that with here on the right side, bottom right, where we actually use braces for the body of the if and the else clauses. I guess some people would say this is a little bit too much typing, because we're typing in an extra, 2 braces for each clause. Well, this one, we don't need to. But, some of the pros and cons here is that this, I've seen errors here where, let's say the logic later on changes and you need to execute 2 statements inside that if clause. Someone could just, type in an enter and then type in a second line without thinking that they need to put in the braces there. So the one on the right side protects against that. What are your thoughts on contrasting these 2?
Well, the other comment that I would make is the one on the left, bottom left. That one is very Pythonic almost. Like if you've worked with Python, the indentation matters a lot, and for that style and the language kind of paradigm and how it expects the syntax to be, I think if you were working with Python and that's how the language was designed, right? So there's no problem doing it that way. But the convention of Java and kind of how people who work constantly with Java expect it to be more of the style on the bottom right, I would say even if it takes some extra typing, I would kind of defer to the language convention.
Yeah, so you would prefer the bottom right over the bottom left.
Yeah. Now, if you were, I guess, comparing the bottom left to the top right, I guess of the two, the top right might be less error prone because if someone was to add something, it would be harder to not put in curly braces, kind of with that example. So even though it makes it harder to read in some respects, probably if you're going to be lazy, then maybe the top right is the best laziness.
Yeah. So true. So if I were to rank this, this would be my first choice. It is a bit more typing, but if I really wanted to save on typing, like you said, then this would be my second choice, because I think it's still fairly readable. Because the body of the if statement is pretty short, so it's not like it's that unwieldy. The one on the left side, the two on the left side. So the bottom left, like you said, I wouldn't recommend because it gives you the false illusion that the indentation matters, but in Java indentation doesn't matter. so it gives you that false. And then the top left, in my opinion, I guess it's confusing because the indentation doesn't really reflect what's happening. We're going to do a shout out. I wanted to do a shout out here to William, because William, your submission works. Like you it returns all the right answers and it covers all the edge cases that we could see. But the main thing is that your code is very, and you mentioned it, I think in your code, you said, this is my spaghetti code. Your code was quite hard to read, and it was very sequential. So I mean, I can follow the logic, but it's very long and very sequential, and maybe it could be hard to maintain also. So a shout out because your code works. Well, a lot of the other submissions we have, the code, misses one or two edge cases. Yours covers all the edge cases. But I wanted to do a shout out just to mention that yours works. But also as we go through the next couple submissions here, maybe you'll see how others approached the problem, and maybe you could see how you could have maybe made some adjustments in your own code as well. Okay. And William, please feel free to comment if you feel that my critique of your code is unjustified. Okay, Ronald.
Okay. So the next example we're going to look at, this student basically considers all the permutations, as the slide says. So this algorithm that the student submitted considers every possible permutation from all the four digits that were the input, and then it would eliminate all the ones that are invalid times. Now finally, the last step would be to determine what is the latest valid time possible from all the permutations. So this submission does that with this code here. It's probably not the best optimal code just because it's using multiple for loops that are nested, but it is what it is and it does get the job done. But there is one issue with this one, and that is with the time 0000. So if we go back to the slide, you can see there is an if else block just right at the end of this slide here, and the if answer equals 0, then we return an empty string. Now it does 99.9% of everything, except because it's checking if the answer is 0, which in fact is a valid time for midnight. It unfortunately does not catch that, and it returns an empty string for that. So close, but just that one case that was missing.
That was my feeling too. So close. Almost. If it weren't for this, this is very readable. But actually, there is one other thing that I'm just looking now. I remember when I see this line here. I understand. It took me a little bit to what are you trying to do here, and I understand it now because you have a magic number 6 here. Why is 6 so special, right? And what you're trying to do here is that you're trying to determine what's a valid number for the last digit, right? But I think if you're gonna and this formula works, but I think it would have been better if you had explained it in a comment, because for someone looking at your code immediately, it wouldn't make sense. Why are you subtracting A, B, and C from 6, and why does that make a difference, right? So that was my one critique about this. Okay. And
so we get to the last submission, which was one of the probably, I guess, the one that is not spaghetti code, and also does all the permutations and calculates the correct answer properly, including the midnight hour, so 0000. And so for this submission, we think it's the best one that we got. So, Roland, do you want to announce who this developer is?
So this is Oscar. So Oscar, you win our sticker again for this week for having what we felt was the best of all the solutions. You still have this little the same critique that I had in the previous one. This magic formula, 6 minus I minus j minus k, to get the index, right, of the last digit. But I would have preferred if you had explained that. But overall, you got all the answers, and I think you got all the different edge cases. So, good job. We'll be sending you out a sticker.
Yeah. This problem, as you can see, looks very simple on the surface, but we still got a lot of different answers and different approaches. But if you have time, I do want to challenge you, and feel free to message the mentors or leave a comment. If you come up with a better answer that doesn't use all these for loops, send us the repo link and we'll take another look at it, and maybe we'll send you some more stickers.
Awesome. Yeah. Okay, great. Well, thank you, Ronald. So, I mean, if you find these videos useful, which I think you are, please give us a like. That'll be very helpful. And like Ronald said, feel free to comment below. And so we look forward to getting more submissions on our next challenge.
Yeah.
Okay. Thanks, Ronald.
All right.
Okay. Thank you, everyone. See you next time. Bye-bye.